Yellowstone National Park is famous for its geysers, hot springs, and most notably its supervolcano. In fact, it's home to the largest active volcano in the United States. But did you know that there are hidden clues buried deep within the rocks that could tell us whether or not it might erupt again? And even more intriguing is that these clues might have been left behind by people who lived thousands of years ago. If you want to find out what secrets ancient rocks can reveal about Yellowstone's future, keep watching. We'll tell you all about it right here. Now, let's get back to those ancient rocks. Yellowstone's magma chamber is more than 40 miles below the surface and spans a massive 43 by 28 miles. It contains enough magma to fill up nearly 100 million Olympic-sized swimming pools. That's a lot of magma. This means that if it erupts, the blast radius will be catastrophic, which is why scientists are constantly monitoring the area for any sign of unrest. The thing is, we can't just wait around and see what happens. We need to find a way to predict when the next eruption might take place. And this is where the ancient rocks come in. Researchers from the United States Geological Survey have found that small changes in the chemistry of rocks near the park could indicate increased volcanic activity. See, the rocks around Yellowstone are full of tiny bubbles of gas called vesicles. They form when magma is pushed up through the Earth's crust and releases gas like carbon dioxide, water vapor, and sulfur dioxide. These gases expand as they rise, creating bubbles in the magma. When the magma hardens, the bubbles get trapped inside the rock. By analyzing the composition of these vesicles, scientists can gain insight into the conditions under which the magma solidified. And this can tell them a lot about the magma chamber below. One of the things that scientists are looking for are changes in the amount of sulfur dioxide in the vesicles. Sulfur dioxide is a gas that is released from the magma chamber as the pressure increases. If the amount of sulfur dioxide in the vesicle starts to increase, it could be a sign that the pressure in the magma chamber is also increasing, which could lead to an eruption. But here's the problem. To collect rock samples from the area, researchers have to drill miles deep into the earth. And this is not easy to do. The drilling process can take months and the equipment is expensive. So scientists are always looking for other ways to get the same information without having to do all of this work. And that's where the ancient rocks come in. You see, there's another way to sample the magma chamber without drilling miles deep, studying rocks that formed during previous eruptions. These rocks contain the same types of vesicles as the rocks that formed more recently, but they're much easier to access. Plus, they provide a record of past activity that can help scientists better understand the volcano's history. For example, by studying ancient rocks, scientists were able to learn that the magma chamber is not just a single unit, but is actually made up of several smaller chambers connected by a network of fractures. This information has helped them to better understand how the magma moves through the system and how it interacts with the surrounding rocks. But maybe most importantly of all, by studying ancient rocks, scientists have been able to develop a better understanding of what a future eruption might look like. For example, they've learned that the amount of sulfur dioxide in the vesicles of ancient rocks increases before an eruption. This is the same type of increase that they're seeing in the vesicles of rocks that formed more recently. So now, they know that an increase in sulfur dioxide levels is a good indicator that an eruption is on the way. But there's even more. Scientists have also been able to learn about the timing of past eruptions by studying the age of the rocks. They've discovered that the intervals between eruptions have varied greatly over time, from as little as 1,000 years to as long as 10,000 years. This information is important because it helps scientists better understand the likelihood of an eruption occurring in any given year. All of this research has helped to improve the accuracy of volcanic eruption forecasts. In the past, the USGS could only forecast the likelihood of an eruption on a yearly basis. Now, they can forecast the likelihood of an eruption on a monthly basis. And that's all thanks in part to the study of ancient rocks. Of course, no one knows for sure when the next eruption will occur. But thanks to the study of ancient rocks, scientists are better prepared than ever before. They can use the information that they've gathered to develop more accurate forecasts and to better protect the lives and property of those who live nearby. Studying ancient rocks has also helped scientists to learn about the history of life in the Yellowstone area. For example, by studying the composition of ancient soils, scientists have learned that the area was once home to a diverse ecosystem of plants and animals, including bison, deer, and even prehistoric horses. They've also discovered evidence of human habitation in the area dating back more than 10,000 years. This evidence comes in the form of stone tools, projectile points, and other artifacts that were left behind by indigenous people who lived in the area. Scientists believe that these people were some of the first humans to inhabit the western United States, and that they may have played a role in shaping the landscape. For example, some researchers believe that indigenous people may have used fire to help control the vegetation in the area. This would have created a mosaic of habitats that would have been attractive to a variety of animals. This in turn would have provided a rich source of food for the indigenous people. In addition to their impact on the landscape, indigenous people also had a profound impact on the geology of the area. For example, they may have been responsible for creating some of the park's most iconic features. The hot springs and geysers of Yellowstone are formed when groundwater is heated by magma from the supervolcano. Some researchers believe that indigenous people may have helped to create some of these features by diverting streams and rivers in order to irrigate their crops. This would have allowed them to tap into the heat of the magma chamber and create new springs and geysers. There's even evidence that indigenous people may have used the heat from these geothermal features to cook food. This would have made cooking much easier and would have allowed the indigenous people to survive in the harsh environment of the Yellowstone region. It's important to note that there's still a lot that we don't know about the relationship between indigenous people and the geology of the Yellowstone area. Much of what we think we know is based on speculation, and further research is needed to confirm these theories. However, it's clear that indigenous people had a profound impact on the landscape and that their activities may have helped to create some of Yellowstone's most iconic features. So the next time you visit Yellowstone National Park, take a moment to appreciate the ancient rocks that have been shaped by the forces of nature and the hands of indigenous people. These rocks are not just a pretty backdrop to your vacation, they're a living record of the history of our planet. They hold clues to the future of Yellowstone's supervolcano, and they tell the story of the indigenous people who have called this area home for thousands of years. We hope you enjoyed learning about the hidden clues in Yellowstone's ancient rocks. If you did, please hit the like button and subscribe so you never miss an episode. And if you have any thoughts or opinions on this topic, please share them with us in the comments below. Thanks for watching, and we'll see you next time.